Hello students, welcome back. Today we are doing a very important question from the JEE Mains 2025. This is a question regarding the acceleration of the image of a moving object in front of spherical mirror. Easily this is the hardest question that JEE Mains has asked on ray optics. So let's begin with the question. The question reads as follows. A driver sitting inside a parked car is watching a vehicle approaching from behind with the help of a side view mirror, which is a convex mirror with radius of curvature equal to 2 meter. Another car approaches him from behind with a speed of 90 km per hour. When the car is at a distance of 24 meter behind him, the magnitude of acceleration of the image in the side view mirror is A. They are asking you to find the value of 100A. So let us first solve this question by the regular approach. Then I will show you a new unseen approach to solve this question. The solution is as follows. The first step would be to find the location of the image. Now the object is placed 24 meters in front of the mirror and it is moving with the speed u. Since the object is placed against the direction of light, we will take the object distance as minus 24. Since this is a convex mirror, it has a positive focal length. So positive radius of curvature divided by 2. So 2 divided by 2. By using the mirror formula, we get the image distance to be 24 by 5. A positive image distance indicate that the image will be formed behind the mirror. So this is the first step. And then we can calculate the magnification produced by this mirror, which is minus V by U. And we plug in the values. V value is 24 by 5 and U value is minus 24. We get the magnification to be 1 divided by 25. So once we have got the object location and magnification, we shall use differentiation to get the velocity relation for the image and object using the distance relations that we have. We have the object distance image distance relation, which is mirror formula. We are going to differentiate it. Differentiation of 1 by v will be minus 1 by v square into dv by dt. Differentiation of 1 by u will be minus 1 by u square into du by dt. And differentiation of focal length is going to be 0 because focal length is a constant. Therefore, if you differentiate focal length, you are going to get 0. We can write dv by dt as velocity of image, du by dt as velocity of object, and we arrive at the velocity relation of object and image in the normal convention, which is velocity of image is minus v square by u square times velocity of object. The term v square by u square can be simply written as magnification square. So velocity of image is minus magnification square times the velocity of object. The next step is to differentiate this relation again and get the acceleration relation. So if I differentiate the velocity relation, I get the acceleration relation. AI is equal to dvi by dt, which is d by dt of minus m square vo. Now one thing we should always remember, mo is a variable. If you change the object distance and image distance, m value will change. So we'll have to apply product rule. So minus m square into dvo by dt plus vo into d by dt of minus m square. Now the first term dvo by dt will be 0 because the object is moving with constant velocity. So rate of change of velocity is 0. The second term is interesting. Differentiating this, we will get vo into minus 2m into dm by dt. We need to get the value of dm by dt. So I have worked out dm by dt on the LHS over here. Dm by dt is d by dt of f divided by f minus u. Note that I am not using minus v by u here. It will become very lengthy. So I am using f divided by f minus u. So on differentiating, we are going to get f divided by f minus u whole square into minus du by dt by chain rule. So now I will put the value of vo. The velocity of object is 25 meter per second. So velocity of object can be easily gotten. Here it is given 90 km per hour. Multiply 5 by 18. So when you multiply 5 by 18, you will get the velocity of object in meter per second. 90 into 5 by 18 will be 25. So we are going to substitute that towards the end. So right now I can put the value of dm by dt here, and minus 2m v naught into m square by f into v naught. This gives minus 2 m cube v naught square divided by f. So now if I plug in the values of magnification as 1 by 25 and velocity of object as 25 square, I will get the value of a as minus 2 by 25. They are simply asking magnitude of 100a. So on multiplying this by 100, we get 8. And that's your answer. Okay students, so now let us see a totally new approach in order to solve this question. So in the NCERT, we use the Cartesian coordinate system of sign convention for finding object and image distance. In that convention, we calculate the object and image distance from the pole, right? There is another convention, brand new convention, in which you do not calculate object and image distance from the pole, but from the focus of the mirror. This convention is called the Newtonian system, and the formula that we get from it is called the Newton's formula. If you see, the object and image distance relation from the focus is xy is equal to f square. It is way more elegant compared to your mirror formula. Your mirror formula has a complex LCM taking and solving in order to get the image distance from the object distance. However, in Newton's convention, the relation between object and image distance is very easy, and many times we can get the answer mentally. Also, the magnification in Newton's convention is minus f divided by x. So let us use the Newton's convention to solve this question. Okay. So what we will do, solution by Newton's convention. Now the object distance has to be measured from the focus. Since the focus of a convex mirror is behind the mirror, in Newton's convention, the object distance won't be 24 meter, it will be 25 meter. It's 24 meter plus 1 meter from the focus, right? So if we use xy is equal to f square, which is the mirror formula in Newton's convention, y will be equal to f square by x. Image distance is equal to f square divided by x. Now, your velocity of image is what? dy by dt, which is minus f square by x square into dx by dt, which is minus f square by x square. What is dx by dt? Rate of change of x. X is changing only due to movement of object. So it is VO. Now, we can directly differentiate this. Why? Because we do not have multiple variables. The only variable over here is x square. Velocity of object is constant. Focal length is constant. So again, you can directly differentiate it without calculating anything. So if you differentiate it again, minus f square VO is a constant. Differentiation of 1 by x square will be minus 2 by x cube into dx by dt. So now all you need to do is plug in the values. Dx by dt again VO. So finally you get 2 f square VO square divided by x cube. But we know velocity of object is 25. We'll plug that in. Focal length is 1 meter. We'll plug that in. And the object distance in Newton's convention from the focus is 25. We'll plug that in. You directly get the value 2 by 25. And so the value of 100A is going to be 8. So in Newton's convention, we did not at all have to first find velocity. You could directly differentiate it, and the acceleration differentiation was very easy in Newton's convention. So kindly practice Newton's conventions. Alright students, so now finally I am giving you a mock question which is of the similar nature. Here also you have to find the acceleration of the image in the side view mirror of the car, and here also you have to report the value of 100A. So kindly solve this question and please comment your answers in the comment section and like the video. Thank you.